Today we are going to start with midpoint formula. So get your notes out and title it Midpoint Formula. We're going to learn how to find a midpoint, an endpoint, and a fractional distance. So we have a lot to cover today. Really exciting day. Determine the truth value of the statement. If false, change the statement to make it true. So write this statement down in your notes and then decide if it's true or false. If K is the midpoint of segment DG, then 2 times GK equals DG. So remember, when it says determine the truth value, it just means, hey, is this sentence true or is it false? So you should be writing the sentence down only what's in green, and maybe you're sketching a picture. Awesome job. So you wrote the sentence down in your notes, and you determined that the truth value was true. The validity is true, right? And hopefully you drew a picture. Let's draw a picture to give us some insight into midpoint. If K is the midpoint of DG, then 2 times GK equals DG. That has a lot of stuff in it. First it says if K is the midpoint of DG. Do you guys know how to mark on your picture that K is in fact the midpoint of DG, of segment DG? How do you mark it? If K is the midpoint, you add what we call tick marks. That's what we call them in geometry. You add tick marks to segment DK and segment KG. When you're adding those tick marks, what are you saying? And I want you to be writing these things down in your notes. When you add those tick marks, you are saying that segment DK is congruent, good, to segment KG. You're saying that the distance from D to K is equal to the distance from K to G. So all of these things are things that your prior knowledge has about a midpoint. We know K is the middle. We know that KG is half of DG. We know DK is equal to KG, so on and so forth, okay? Moving on, we understand what a midpoint is. All right, so Vanessa drew a line segment 5 centimeters long. So she took the ruler, she drew a line segment 1, 2, 3, 4, 5 centimeters long. She needs to locate a point on the segment for which the part of the segment on the left is identical to the part on the right. How would she do this? So Alex said go to 2.5. Like on the ruler, go to 1, 2.5. Alex, how did you get 2.5? Okay, so you took the length, you took 5, and you divided it by 2. What's another way to put that algebraically? Dividing by 2 is the same as multiplying by what? Do y'all know? Good. It's the same as multiplying by 1/2. So that's going to come up later when we do fractional distance. Okay, so we could use numbers. We could take the length divided by 2 and find that number on the ruler. Okay, now you lost your ruler. Okay? You don't have your ruler anymore. You just have a segment on your piece of paper, and your segment is 5 centimeters long. How do you find the middle of that segment? You don't have a ruler. Are y'all going to let Alex answer everything? Yes, I wanted you to say that. You take your paper, pretend this is there, and you fold your paper. You fold your paper to where one endpoint lands on the other endpoint. You crease your paper, and where that crease is in the paper, you have located the midpoint. Very good. So we could fold our paper. We could measure with a ruler. We could take the length and divide by 2. Okay. Just like yesterday, we learned how to find distance, 1D distance, and we learned how to find 2D. Let's go over it. To find 1D distance, we said find the absolute value of the difference. We said subtract and divide by 2. Subtract and divide by 2. To find the distance on the coordinate plane, we had to use this guy. You know what I'm talking about. I'm not going to write any more. Okay? So 1D distance number line versus 2D distance coordinate plane. Now today we're going to find out how to find the midpoint on a number line, and it's going to be one step less than having to find the midpoint on the coordinate plane. Alright, so let's look at what you did in class flow. Given point A is at -2, good job. You plotted point A and you wrote down the coordinates. Point B is at 4, good. You plotted point B and you wrote down the coordinates. Find the midpoint of AB. I purposely made this extremely easy because I wanted to talk about the different strategies, okay? The answer, of course, M is 1. You're right. But I want to talk about the different ways that we got there. Now, I noticed some of you, my writing's not going to go away. Some of you counted. I could see you counting, right? Cool. What methods could you use to find the answer of 1? Someone give me a method. Okay, let's stop there. Jesslyn said the absolute value thing. So you're saying find the length, because that's what you use that for. Find the absolute value of the difference, subtract them, and you're saying find the length, right, Jesslyn? And then divide it by 2. But the answer wasn't 3, and then what do? And then you have to count 3. I agree with you that that gets us a midpoint. Find the length, divide by 2, and then count. But that sure seems like a lot of steps just to find the middle. That was at least 3 steps. If you count the actual subtracting, it's like 4. Okay, guys. On the first quiz, you got a 90. On the second quiz, you got 100. What's your average in the class? 95. What did you do? You added them up and divide by 2. You found the middle of your 2 grades. Did you find the distance first? Did you do 100 minus 90 and get 10, and then divide 10 by 2, and then add 5 to 90? No! You did not do all of that under here. That's not efficient. You found the middle by adding them up and dividing by 2. It's called an average. It's called a mean. Could you have done this on that number line? Add up the endpoint and divide by 2. What's -2 plus 4? It's 2. What's 2 divided by 2? Oh my goodness, it's 1. So no, you don't need to find the length and divide the length by 2 and then add it. I don't want you to find the length at all today. I want you to simply find the average, find the middle. Try this example. Consider points E at -16 and F at 92. Find the coordinate of the midpoint. Go. So we learned that to find the midpoint on a number line, you're finding the middle. You're finding the average. Do not find the length. Do not find the length. What did I tell you to do? Add them up and divide by 2. Well, wait a minute, Miss Tanton. Does it work if one's negative and one's positive? Yes, it does work. Okay, so what is -16 plus 92? 76 divided by 2. The answer, M, is 38. That is the one and only midpoint. Can a segment have more than one endpoint? Midpoint? Can a segment have more than one midpoint? No. There's only one middle to a segment. Now, let's pretend we're not sure if we did that right, because some of y'all got the wrong answer first. How could we check that answer? How could we check or verify our answer? Now we can do what y'all were trying to do. Now I'm going to allow you to find the length. I want you to find the length of the M. When you find the length, that's a subtraction. That's a difference problem. What's the difference in 38 and -16? When you find the length, that's when you subtract. What's the length of MF? 92 minus 38. Since they both equal 54, I have just verified, it's kind of like proving, but not exactly. I have verified that M is the midpoint. I backed it up with math. Okay? Okay, so I just sent you a slide in class flow, and I want you to find the midpoint of my segment. But my segment is no longer one-dimensional anymore. It is now on the coordinate plane. It is diagonal. I want you to find the midpoint using your pen in class flow, and then you need to be able to back it up with what strategy you used. When you know the coordinates of the midpoint, submit it. Got that? Do not use the distance formula. Do not find the distance. Do not find the length. We are not using that strategy here. Trying to find the middle, the average. Got some interesting things. Wow, that's a really big midpoint. Okay, so you got 6, 4 over 6 up 4. What do we have here? Oh, 6, 4. Okay, you located it. We just need to write the coordinate. You did a great job. Trying to see if I can see how y'all got it. You're not, ooh, I like this. A smiley face. Ooh, mathematical. Okay, let's talk about this. I want you to take a look at this one because I gave you such a simple problem on this first one because I wanted you to do it this way. Okay? Now, to get from 3, 3 to 9, 5, how many do you rise and how many do you run? Well, to get from here to here, I rise 2 and I run 1, 2, 3, 4, 5, 6. Rise over run, slope, right? Rise 2, run 6. Now, if I want to get to the midpoint by counting, I would rise half of the way and run half of the way. Good. So I'm not going to rise 2, I'm going to rise half of 2. I'm going to rise 1. I'm not going to run 6, I'm only going to run 3. And boom, I made it to my midpoint. Now that I have my midpoint, I have to actually see what the coordinates are. It's over 6 and up 4. So yes, the answer was 6, 4. Counting the slope and going halfway up and halfway over is one way to do it. Let's talk about another way to do it. Because what if this is on a huge coordinate plane and those coordinates are in the thousands? And you're not going to sit there and literally count every block, right? So let's talk numerically about how we're going to do this. Now, when we found it on a number line, we just added them up and divided by 2, right? So, could we do the same thing here, but just average the x's and then just average the y's? Would that work? Let's see. Add my x's and divide by 2. Add my y's and divide by 2. 9 plus 3, 12. 12 divided by 2, 6. 5 plus 3, 8. 8 divided by 2, 4. Wow, we got 6, 4. We got the answer using a formula. Okay? So there are 2 ways. There are 2 ways to get it, but this is the formula for midpoint. If you're not on the coordinate plane and you can't go halfway up and halfway over, this would be the most efficient way to find a midpoint. Oh, you already learned it last year. Good. Write the formula down. You now have a distance formula, and you now have a midpoint formula. You don't need to memorize either of them, but you need to know how to use them. In my mind, midpoint is like 5 times easier than distance. I like this formula better. It's super easy. Add them up, divide by 2. Add them up, divide by 2. Plus, I like adding better than subtracting for some reason. Now, we need to talk about this. When you find the distance between 2 points, what does your answer look like? What's your product? What's your output when you find distance? Not a point. When you find distance, what's your answer? What does your answer look like? No. It's a number. A number. Now I'm going to ask that one. When you find midpoint, What should the product, what should the output be? And that's what you were trying to say. So in distance, it's going to be a single number, like 15.2. Your answer to a midpoint problem is going to be a coordinate, not a single number. Okay, let's just try an example. Find the midpoint of segment TR. Go. Okay, while you're getting used to it, I recommend doing just like we did with distance formula. Circle your x's and underline your y's. All right, the formula says add your x's and divide by 2. So I did circle plus circle divided by 2. And then add your y's and divide by 2. Underline plus underline divided by 2. 7 minus 1 is 6. 3 plus negative 7 is negative 4. You do not have to show that step of work. I'm just showing my work just in case you're lost. 6 divided by 2. The answer for the x's is 3. Negative 4 divided by 2. The answer for the y's is negative 2. So 3 comma negative 2 is the coordinates of the midpoint. So now, we're in high school. We're going to go beyond midpoint, right? I don't want you to just find the middle. Oops, I did not mean to make that smaller. I want you to find some fractional distances. I want you to find the point that's 1/4 of the way instead of 1/2 of the way from A to B. Go ahead and try that. So hopefully you've been able to draw on this figure a little bit in class flow and figure out what you want to do. Last time we talked about finding the rise and the run. I rise 2 and I run 6. And we talked about to find the midpoint, just go halfway up and halfway over. But if we only want to go 1/4 of the way, could we use that same method? Could I just take 1/4 of 2 and 1/4 of 6? And actually the great news is that we can. So 2, I'm going to divide it by 4 instead of dividing by 2. So I'm going to take my rise and I'm going to divide it by 4. And I get 0.5. That means I'm going to rise half. 0.5. My run is 6. I'm going to take my run and I'm going to divide it by 4. That means I'm going to run 1.5. So rise half and run 1.5. That, what should I call it? C. That is the point that is 1/4 of the way from A to B. We have to find its coordinates now. We have to find its coordinates. Okay, so I go over 1, 2, 3, 4.5. And I go up 1, 2, 3.5. Now remember, this method of rising 1/4 and running 1/4, when you're counting, it only works if you're on the coordinate plane. And it only works if your numbers are nice and small. Let's figure out how we could have done that with math only. What do you think? What was the midpoint from when we did this earlier? Do you remember what the coordinates were? 6, 4, right? Well, if we want to go 1/4 of the way, then we're going to find the midpoint of the segment created with the midpoint. The midpoint of the midpoint, right? Because 1/4 is just half of a half. So I'm going to use the midpoint formula, and I'm going to find the midpoint of that segment. I'm going to use the formula instead of using the rise over run counting method, okay? So I'm going to use this guy and this guy. Add your x's and divide by 2. Add your y's and divide by 2. All right, let's do it. 9 divided by 2. 4.5. 7 divided by 2. 3.5. And that's the same answer we got on that other slide. So we found a midpoint, and then we found the midpoint of the segment that was created with the midpoint. In other words, we did midpoint formula twice. The answer is 4.5 comma 3.5. Okay, I'm just warning you, this is when it gets K-level, very K-level. It's going to get ugly. I'm going to show you one today, and I'm going to let it marinate over the long weekend, and we'll talk about it more on Monday. It's going to be ugly. I'm warning you. Okay, here we go. Let's find the fractional distance, and our endpoints are -6, 1, 2, 3, 4, 5, 6, 7. That's A, and 4, 1, 2, 3, 4. That's B. All right. I don't want the midpoint. I don't want 1/4 of the way or 1/8 of the way. Those are easy. Those are just midpoints of midpoints. I want 1/5/7 of the way. And that's where it gets a little bit ugly. Okay? What I want you to do, well, we can connect these if we want to. I'm not sure if it's perfect. But we're going to do that method where we find the rise and the run. We find the delta x and we find the delta y. And I'm not doing that. There we go. Let's do that perfect. Let's be perfect. Okay? So follow along with me. I'm finding delta x and delta y. And then we're going to take 5/7 of that. Okay. Let's find delta x. I can count or I can subtract my x's. So delta x is 4 minus -6 is 10. Or I could have counted 10 spots, okay? It's 10. Now let's find the change in y. I can count, or I can just find the distance between 7 and -4. Sorry, it's 11. We need 11. Okay. We found delta x and we found delta y. Now, we have to multiply those by 5/7. And that's why I warned you that it was not going to be pretty. I don't want to multiply it by half. I don't want to multiply it by 1/4. I have to go 5/7 of the way. This is when we let our calculator do the work. Okay? 10 times 5/7. You know what you get? 7.1. We're going to round. 11 times 5/7. You know what you get? 7.9. I am rounding. Okay. So now we're going to either, you have two choices. You can add those points on here, or you can travel that distance on your graph. Like delta x, you can go over, starting at A, you can go over 7.1 and down 7.9. Let's do it. Let's go down. 1, 2, 3, 4, 5, 6, 7, and a little bit more, 0.9. And then over 1, 2, 3, 4, 5, 6, 7.1. Kind of about there. See that right there? And we would have to find the coordinate of that point. Another way to do it numerically is what I was talking about. Take this and add it to that. And then take this one and move from that, subtract it from that because we have to go down. Okay? So 7.1 minus 6, so our coordinates are 1.1, comma, 7 minus 7.9. We're going down 7.9. I know that's awful. I know it's ugly. Just let it sit for a while, and we'll talk more about that on Monday. It says take a deep breath. Because now I'm going to show you one more thing, and it's really easy. Really easy. Ready? Okay. Find the end point of a segment. Find the end point. So if you're taking notes, you would put end point in your notes. Okay. So in this problem, I already know the midpoint. They gave me the midpoint. It's like Jeopardy. They gave me the answer, and I need to solve for the question. So I already know the midpoint, and I need to find out what the other endpoint is. And what we're going to do is play leapfrog. That's why there's a frog on there. I think he makes noise. He's supposed to read it. Anyway. Okay. So how we're going to do this is we're going to ask ourselves, how far do you leap if you have to go from 2 to 7? How far do you leap? Well, that's plus 5. How far do you leap to get to your next endpoint? Well, you just go the same amount again. So you leap 5 and 5. So I'm at 7, and I want to leap 5. Get 12. Cool. Now let's do the y. From 9 to 3. 9 minus 3. How far is it from 9 to 3? We're going backwards 6. We got smaller. That's not a distance. That's just what we're leaping. So I want to go backwards 6 again. 3 minus 6 is negative 3. And that's how you play leapfrog. The answer is 12, negative 3. I'm going to show one example and then I'm done. Okay. If B is the midpoint of AC, find the coordinates of C. So that's an endpoint. When you set up to play leapfrog, you have to put the midpoint in the middle. See how they gave it to us first? Don't put it first. Put the midpoint in the middle. Midpoint, middle, midpoint, middle. And then I can put this guy over here, and then this will be C. So this is B, and that's A, and we're trying to find C. All right, let's do it. Let's do our X's first. How far do I leap? Negative 3. So I go negative 3 again. Negative 3 minus 3, negative 6. Okay, now let's do our Y. From 15 to 7. We're going negative both times this time, right? Negative 8. So I want to go negative 8 again. 7 minus 8, negative 1. So our answer, the coordinates of C are negative 6, negative 1. Just played leapfrog. You leap the same amount both times. You do it for the X's, and then you do it for the Y. Okay. You have homework this weekend. Enjoy your 3-day weekend, and you have plenty of time to do that homework. See you Monday, Tuesday. See you Tuesday.